In this practical, we will study and verify the behavior of clipper circuit using multisim. There are many types of clipper circuit, but for demonstration purpose, I will take first series positive clipper circuit, second series positive clipper with positive bias, and third is combinational clipper circuit. So we will use multisim simulator to see the demonstration of this practical. So in the multisim simulator, you have to place the components. First component is your diode. So go to the place, click on component. In this, you have to take diode as a component. In this diode series, we have to take 1N4007 series diode. So this 1N4007 diode is present here. So I am taking this diode, placing in this working area. Now this is a positive clipper circuit. So in positive clipper circuit, the cathode of the diode should be on the left side according to the circuit diagram, and therefore I am pressing Ctrl R to change the rotation of this diode, and then I am placing it on this working area. Now I want to take second important element as a resistor. So I am taking this resistor from this component list, resistor rated, press OK. Resistor should be placed vertically, so I am pressing Ctrl R so that I can place this resistor vertically. Now I am connecting this circuit diagram. So the anode of the diode should be connected to one terminal of the resistor. The cathode of the diode should be connected to the another terminal of this resistor as per the circuit diagram. So we will be connecting it to it. Now we have to give the ground to this circuit. So I'm going to place component. Inside this, you have to go to the sources, power sources, and inside the power sources you find there is one option ground. Click on that ground and press OK and place this ground terminal in the circuit. Now connect this ground terminal to the circuit. Now to find and to observe the input and output waveform of this clipper circuit, we are connecting function generator and CRO in the circuit. So to do this, you have to go to this right hand side, extreme right hand side, you find this palette where the function generator is written. So click on this function generator and place it at the input side of the circuit. Similarly, to observe the output waveform, we have this oscilloscope. Click on this oscilloscope and place it at the output side of the circuit. Now, input is given from this function generator. So the positive of the function generator is connected at the input side of the circuit, while the common terminal is connected at the ground side. Similarly, this B channel of the CRO, we will connect it at the output side to observe the output waveform. So I am connecting the B channel of the CRO to observe the output waveform, and its negative terminal is made common to the circuit. Similarly, we have to connect channel number A to observe the output waveform. We are connecting to observe the input waveform on the CRO. I am connecting channel number A to the function generator, while its negative terminal is made grounded. So this is our complete circuit diagram for this series positive clipper circuit. Now to change the input voltage, we have to click on the function generator. After double clicking on the function generator, you can change the frequency. Let us consider I have to select 1 kHz frequency. So I am selecting 1 kHz. Let this amplitude is equal to 10 volt only as it is, and I am selecting the sinusoidal waveform as an input signal. So after clicking this, you can close this, and now you can run the simulator. But before running, you can change the color of this input and output net so that we can differentiate the input and output signal very easily. So to do this, you have to double click on the input net. I'm changing the color of this input to the blue. Similarly, we can change the color of this output side either to any color or let it be as it is. Now I will click on the run simulator and then double click on the CRO. You can find here the frequency of this is very high. So to reduce this frequency, I am changing the scale of this waveform. Now we can easily observe that input waveform which is shown in the blue color and the output waveform is in the red color. If I will stop or pause the simulation, you have to click on this pause button. Then you can find out that the complete positive portion of the input sinusoidal waveform is get clipped off, and therefore the circuit is called as a positive clipper circuit. Now we can invert the color of this background of this CRO screen to white. Just click on this reverse button and you can find out that the background color is changed to the white. So this was our practical number 1, which was series positive clipper circuit. Now to take a series positive clipper with a positive bias, there is only one small change required to make in a circuit, where I have to connect a battery, external battery, to the circuit. So it will be connected at this resistor R1. So I am placing this resistor R1 here, and now I am placing one more component in the circuit, that is nothing but I have to first stop the simulation. We have to first place another component in the circuit, that is a DC power supply. So in power sources, you find there is a DC power, and just click on this DC power and place it in series with the resistor. Once you place it in the series with the resistor, I can change the value of this external battery from 12 volt. Just double click on it and you can write 3 volt. So this circuit is called as series positive clipper with a positive bias. Now again I will simulate this circuit. Click on the run button and double click on the CRO. So here you can find out that some part of the positive cycle is get clipped off depending on how much external voltage you are applying. If I pause this simulation, then you can easily notice here that some part of the positive side of the signal is get clipped off and complete negative cycle is available to us. So this clipper circuit is called as series positive clipper with positive bias. Now we have to perform one more circuit here, which is called as combinational circuit. So in combinational circuit, both the cycles are get clipped off depending on how much external biasing voltage is applied. So I am making a changes in the same circuit diagram. First I will stop the simulation, then I will make a circuit according to the combinational circuit like this. Let me remove this diode first from the circuit. I don't require this resistor also. Resistor is to be connected in a series now. Now the circuit for this positive combinational circuit is like so. First I will be placing diodes in a circuit. So go to the diodes, as we have to take 1N4007 series diode. So take that series diode from here, place it in the circuit area. Now the first diode should be connected like this. So I am pressing Ctrl R to change its direction. Similarly, I required one more diode for the combinational circuit according to the circuit diagram. So I am placing one more diode in the circuit. Now in series to that, I have to connect a power supply. I am going to sources, DC power, and here you place one battery in series with the first diode. Similarly, you have to place another voltage source, but the negative of this is connected to the anode of the second diode, and therefore I am pressing Ctrl R so that the negative terminal of this battery is connected to the anode of the second diode as per the circuit diagram. Then connect this diode and battery in the circuit. So I am connecting it as per the circuit diagram given. Similarly, the second diode is also to be connected. Now in this case, we have to place a resistor in a series arm. Therefore, I am placing one resistor in the series arm. So place component, then you go to the all groups and there you can find resistor is there. Place that resistor at the input side of this circuit, and this function generator is to be connected to the resistor side. So this is our complete circuit diagram where input signal is also applied and the function generator is also connected to the circuit. Now I want to observe the input and output waveform of this circuit. So to do this, we have to connect the output of this CRO to the second channel. So I am using B channel to check the output, to observe the output, while A channel I am connecting to the input of the function generator. So this way I am connecting the function generator. We have already set the signal value to 1 kilohertz and 10 volt. So again we will not change it. Now this circuit diagram is completed. Now you notice here we have two voltage source. So change this voltage source to 3 volt instead of 12 volt. So I am selecting this V1 is equal to 3 volt. Similarly, select this V2 is also equal to 3 volt. You can take any other value depending on your requirement, and now click on the run button. If I double click on the CRO, you can find, if I pause this simulation, then we can easily observe the input and output waveform. So here you can see, both positive as well as the negative portion of the cycle is get clipped off depending on how much biasing voltage we are applying. So this is the combinational clipper circuit.